Let's make it darker. Okay, so here's, all right, here's the first group. So let's get a stat plot on. Let's turn you off. Scatter plot, L1, L2, I think that's right. This looks roughly what you guys got?
Yeah, will you do that again?
Oh, I'm sorry.
Scatter plot.
Oh, second y equals. You guys hold off on your scatter plot though, yes? Unless you're doing this one too. Are you doing both of them? Are you doing the coin flips and the cards? You guys hold. I think we're gonna change your data a little bit, but we'll do it together, so I don't lose anybody. So you guys just hang tight while we do this side of the rooms. That's fair. So here we go. I want to change. That's a little annoying looking. I want to change the scale on that y-axis to make it not so silly. Make this 300 by 50 is not bad. I'll make it 30 just to make it make 10 tick marks that way. Okay. So one thing you could very easily do with this is put a line through it. But, I mean, who's going to put a line through that, right? This was the argument we had in class yesterday and the day before about my speed going down that hill on my bike. I mean, yeah, you could connect a line from here to here. Chloe, you actually asked about this about the quiz, right? You could give me the average rate of change from there to there. But it's kind of meaningless, right? It ignores what's actually going on in the shape of the data. So how many of you guys tried a quadratic progression? Looks like kind of like parabola, yes? Let's do it. Let's do it. Cal, quad reg. I think that's a good idea. Stick it in y1, yes? Okay, there it is. Gives me a nice equation. A is 6 point blah, B is negative blah, 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 blah. Here it comes.
Oh, it's 1 point.
Well, okay, now Aaron brings up a very, very good point, no pun intended, point. And that it only hits 1 point, and arguably it might not even hit that one. It looks like it hits that one out on the axis there. But Randall, what else is bothering you?
It's not hitting anything else.
Okay, now remember friends, hitting the points isn't crucial. What's crucial? Do you remember why they're called regressions, why they're called least squares regressions?
I'm trying to get the standard deviation as low as possible.
Right, it's not so important that you hit the points, it's that on average you miss them the least. I don't know if that makes any sense. Does that make any sense?
Yeah.
So what you want to do is you want to have a curve, a smooth curve hopefully, that misses the points as little as possible. So minimizing the error. There's a lot of error on this. There's a bunch of error there, there's a bunch of error there, a bunch of error there. Carrie, what were you going to say? You were going to say something else?
No, I picked a different one.
You did. Yes, and Carrie noticed, this is what I noticed. If you look at this model, what it says is we should be dropping as we increase the number of times it took us to find heads. But then past the point, we should start seeing more people take even more flips. Does that make sense? Because think about it. What was happening was in the beginning of that experiment, I had to actually use the calculator to add up all the fingers that were up in there because there were so many of them. But by the end, there were only 1 or 2 fingers up for random people. So does it make sense that the model predicts there should be a resurgence? That doesn't make sense, does it? So that's a problem with the quadratic model. Not to mention the fact that the error is large. What else did you guys try? Did you just keep going down? Cubic reg? Absolutely. Just FYI, let's run it. We'll do the same thing with your guys' data too. You guys just kind of let this wash over you right now. Cubic reg, y1, same exact thing. Okay? It's going to give you coefficients. Now you got to remember, we haven't talked about this much. I have a really fun problem for you guys to do on your last exam that involves Usain Bolt and his 2009 world record time in the 100 meters. That actually uses a cubic regression. It's pretty fun. A linear regression would force a best fit line through your data. A quadratic regression would fit a best fit parabola, whether it's like this or whether it's like this. What is a cubic? Well, that's what a cubic looks like. Something x cubed plus something x squared plus something x plus something. But what shape would a cubic have? How many of you studied this in your previous math classes? Maybe a couple of you. Go ahead, Randy. Go ahead. General shape. What's it gonna look like?
It's gonna either go down and keep going down. It's kind of like this.
Did everybody see the shapes you just traced with their hand? Will, it's an S, yes? It's an S shape, generally. And I love going down and keep going down. Love that. It's fantastic. So in other words, they're either going to have, they're going to start, go high, come down low, and then go back high, or it's going to start high, come down, turn, and turn. Essentially, every time you add a higher powered term, you pick up one more curve on your curve. So a line has 0 curves. A parabola has 1. A cubic has 2. There we go. Infraspinatus muscle, I can feel it right now. A quartic would have 3. I'm not going to pretend to do that one. So in other words, let's take a look what it looks like. Where's the hump? You see it? You see the turns? It came down. Look how well it's fitting. Yes, it's fitting very well. And then it humps up, which is kind of weird. That's a little weird too, right? And then it dives down, which is also, now I love the way this fits. It fits gorgeously, doesn't it? It fits gorgeously. What's the matter? That was very exciting sounding. However, what's the however?
You can't have negative times.
Okay, so there is a realistic issue here. Do you guys think that it would be possible that eventually somebody would have to flip the coin 10 times until they saw heads? Or 12 times until they saw heads? Or 13 or 4? It's possible, isn't it? So it is possible that somewhere out here, and I bet you if we had you flip the coin another 100, 200 times, somebody would eventually fall. Hell, I almost did. I had 6 times till I saw it, which only happened 0, 1, 2, 3, 4, 5, 6. There's what happened with me. So this negative thing over here is making me a little bit nervous. This negative dive. I love the fit. It's just that dive is making me nervous. So Aaron said, let's get rid of the dive. Let's put a quartic regression on. So you just keep going. Hang on, hold that thought. You're solving problems for us here already. Yes, you are. No. Aaron said he's questioning, but that's actually solving problems as we go. So quartic is the next polynomial up. It would have an x to the 4th power. So let's see what it looks like. See, it has 5 coefficients, or 4 coefficients and a constant. So you got x to the 4th, x cubed. It says dot, dot, dot. There's an x squared. There's an x to the 1st. There's an x to the 0th, which is the constant term. Look how well it fits. Here she comes. Now, it's going to be hard to see them. It's very hard to see them, actually. But there's little tiny micro humps in this one. Remember how we pick up a turn every time you pick up a degree? That thing has little tiny micro humps on it. It's very hard to see with the resolution the TI gives you. But again, we're back into the same problem we were with the last one, aren't we? The tail shoots back up again. Now I'm going to give you 30 seconds of a Math 111 lesson. Just 30 seconds! I just wasted 2 of them. When you have even-powered polynomial functions like this one, x to the 4th, x squared, x to the 6th, x to the 8th. Remember how a parabola goes like this? Do you see how the 4th power one kind of goes like that too? Its tails match, they both point up. Well, it's got some humps in the middle, but at the ends go up like this. A 6th power one would too, if your TI lets you do a 6th power, which it doesn't. An 8th power one would too. A 10th power one would too. The odd powers, the linears, the cubics, the quintics, they have mismatched tails. Lines look like this, or like this. Cubics go like this, or like that. It's like the bangles right now. 5th powers would have 4 humps, but they would have mismatched tails. And hopefully that makes sense. If you think about the number of turns it takes, it has to go opposing directions. Cubic turns twice, yes? So if it's coming down, it turns, then turns a second time, and it keeps going down. A quartic turns, 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 and it goes back up. So every time you add a degree, you add a turn, which is going to change the way the tail's going. So that's the 30 seconds? I think it did. About 30 seconds. But that's also enough time to realize that none of those models make any sense with our data, do they? No, none of those models make any sense with our data. Because we don't have a tail at the end of our data that shoots up or that shoots down. What is our tail doing on our data? Say that again, Brittany. You see what our tail of our data is doing? I'm going to pull this model off. I'm going to pull this model off. See that equation before I hit delete? How ridiculous that thing was? It took like 12 lines. And this is ridiculous. You have to realize what the TI is doing right now with these models would take us days, if not weeks, to do by hand. I mean, it's ludicrous. Remember the whole linear regression that we started this all with 4 weeks ago? We used to have to do it manually. And it would take a full hour's class to do a 5 data point best fit. Nobody ever does quadratic or cubic or quartic regressions by hand because it's time prohibitive. It's stupid to even think about. So, what's the general shape our data is doing? Well, it looks like a parabola for a while, yes?
It's like a slip and slide.
It's like a slip and slide, minus the suicidal OSHA non-approved ramp at the end that would break your face. Speaking of which, have you guys seen that faked video of the crazy Germans with a slip and slide into a bucket?
Yeah.
Have you seen that one? It's video shot. It's fake. But there's a slip and slide set up on a mountain in, I think it's Germany or Switzerland. And there's a dude, Google it when you get out of here. And it's a dude on a slip and slide, and he has like, puts a helmet on, like pads and stuff, like go, 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 and he gets on this mountain, and you see him rocketing down the slip and slide, hitting a ramp, and then he disappears out of the top of the frame of the video, and then the video camera goes like this and looks down, and there's a bucket, like a big, like a wash tub that's about 3 feet deep, and you see him go into the bucket, and he gets up, he's like, yes! And I'm watching that going, how is he not dead? Because that would kill a human being, and it turns out it's faked. But it's freaking awesome. It's totally worth watching. Slip and slide, crazy German. Google it. Or crazy Swiss, I'm not sure which. Crazy slip and slide mountain or something like that. You'll find it. You'll track it. There's probably 8 million views. Anyway, take out the crazy ramp. Sorry, Kendra, it's a bit of a tangent. Take out the crazy ramp at the end, and it is a slip and slide that's coming down a hill, if you will, and then flattening off. And then flattening off. So the question I have is there any predictability about what that data is doing? Is there a model in your TI? And the answer is hell yeah, there is. Did anybody find it, which model it was in there? So go back into your TIs. We'll spoil the surprise a little bit. We'll go back and analyze.